Hello and welcome, dear viewers, to our YouTube channel. I'm thrilled to have you here today as we dive into the fascinating world of physics-informed machine learning for Earth and environmental sciences. In this episode, we'll explore the cutting-edge field of physics-informed machine learning and its exciting applications in understanding and predicting various phenomena in Earth and environmental sciences. It's a topic that combines the power of machine learning with the fundamental physical laws that govern our planet and its complex systems. As technology advances, we find ourselves collecting vast amounts of data from sensors, satellites, and monitoring networks. However, making sense of this data and harnessing its predictive potential can be a daunting task. That's where physics-informed machine learning steps in, allowing us to incorporate our deep understanding of the physical world into powerful predictive models. Physics-informed machine learning combines the best of both worlds: the data-driven capabilities of machine learning algorithms and the domain knowledge of physical principles. By integrating the laws of physics into our models, we can enhance predictions, improve interpretability, and gain insights into complex Earth and environmental processes. In today's video, we'll explore how physics-informed machine learning is revolutionizing climate modeling, weather prediction, environmental monitoring, geophysical exploration, hydrological modeling, and even ecology and biodiversity studies. We'll delve into real-world examples, showcasing the role of this emerging field in solving critical challenges and driving innovation in Earth and environmental sciences. Whether you're a student, researcher, or simply curious about the wonders of our planet, this video will provide you with a deeper understanding of how physics-informed machine learning is shaping the future of Earth and environmental sciences. So, fasten your seatbelts and get ready for an incredible journey through the fascinating world of physics-informed machine learning. Don't forget to hit the subscribe button and turn on the notification bell, so you won't miss any future episodes where we explore more captivating topics related to Earth and environmental sciences. Hey ML, can you explain to us the use of physics-informed machine learning in the context of Earth and environmental sciences?
Yes, absolutely. So, physics-informed machine learning combines the power of machine learning with the fundamental physical laws and principles that govern various phenomena. It has gained significant attention in different domains of Earth and environmental sciences due to its ability to incorporate domain knowledge, enhance predictive capabilities, and improve the interpretability of machine learning models. There are many examples of physics-informed machine learning in different domains. For example, in climate modeling, physics-informed machine learning can be applied to improve climate models by assimilating observational data and incorporating physical constraints. It can help to bridge gaps in understanding and predict complex climate phenomena such as cloud formation, precipitation patterns, and ocean circulation while respecting fundamental physical laws. In addition, by integrating meteorological data with physics-based constraints, PIML can enhance weather prediction models. It can assimilate real-time observations, such as radar data, satellite imagery, and atmospheric soundings, and combine them with the underlying physics equations to improve short-term and long-term weather forecasts. PIML can also be used to analyze and interpret environmental data collected from sensors, remote sensing platforms, and monitoring networks. By leveraging physical principles, machine learning models can identify anomalies, detect environmental hazards, and predict changes in various environmental parameters, including air quality, water quality, and soil contamination. Physics-informed machine learning plays a significant role in geophysical exploration techniques. It can help in seismic imaging, subsurface characterization, and reservoir modeling by integrating physical laws and constraints into data-driven models. PIML can enhance the efficiency and accuracy of geophysical surveys, leading to better resource assessment and exploration. PIML can also improve hydrological models by incorporating physical laws governing water flow, infiltration, evapotranspiration, and groundwater movement. By assimilating observational data from sensors and stream gauges, machine learning models can provide more accurate predictions of river flow, flood events, and water availability, enabling better water resource management. Last but not least, physics-informed machine learning can assist in ecological and biodiversity studies by integrating physical factors, such as temperature, precipitation, and soil characteristics, with biological data. It can help understand species distributions, ecosystem dynamics, and ecological processes, aiding in conservation efforts and ecosystem management. Overall, physics-informed machine learning has the potential to revolutionize earth and environmental sciences by combining data-driven approaches with the fundamental physical understanding of natural processes. It enables more accurate predictions, better understanding of complex systems, and enhanced decision-making in various domains related to the Earth and the environment.